In this example, we are going to be revolving around other lines. So we're not going to revolve around an x-axis or a y-axis. We're going to revolve around just some horizontal line or vertical line. So we're going to find the volume of a solid in the first quadrant that is generated by rotating around the line y equals 2 and bounded by this square root graph and y equals 2. All right, so let's create ourselves some sort of a visual. Okay, and we are rotating it around this y equals 2. So this graph right here is a square root graph that's shifted up 1. So that graph is going to start here. And then we have this y equals 2 line, which is here, which is actually what we're rotating it around, and we're bounded by it. Okay, so our square root graph kind of has this look to it. And so we need to figure out what this looks like when we rotate it around this. And so what we need is this distance, this height, basically, because that's our radius. Because if we're finding a volume, it is the area of the base times the height. We're making these little cylinders. And the area of the base on the cylinder is pi r squared times the height. And so we don't have a washer or anything like that. There's no hole that we have to consider. We just need to figure out what this gap is. All right, so here's how we do this. We have two things that we have to consider, because right now our radius is, if it basically could just be all the way down, that would be 2. However, we need to subtract out. So this whole thing right now, the radius is 2. But we need to subtract out this piece to have left this little gap, because it's constantly changing. It's all changing depending upon kind of how long this piece is. And so that piece that we are going to subtract is going to be the heights of this equation, square root of x plus 1. So if you take 2 minus this, you have left this little piece right here, and that's our radius. So our radius is going to be 2. We're constantly have a height of 2, but we need to subtract away this piece right here. So minus the square root of x plus 1. So if I clean that up and do a 2 minus the square root of x minus the 1, I'm really looking at a 1 minus the square root of x is really what I'm looking at for my radius. So my radius into my volume formula is pi. The radius squared is this equation. So 1 minus the square root of x squared, and then dx. And we are going from 0 to that point right there of when this equation equals 2 is you would plug in a 1. Square root of 1 is 1 plus the 1. So that is going from 0 to 2. Sorry, not 2. Plugging in 1, getting a 2 is a 1. So we're going to go from 0 to 1 is our bounds. All right, so let's do the math. So our math is, let's clean this up. I really don't want to have this. I could go ahead and distribute this out. I'm going to pull the pi out always, 0 to 1. If I were to multiply 1 minus the square root of x times another 1 minus the square root of x, I get 1 minus 2 square roots of x's plus this one times itself, so just an x dx. So one more thing of cleanup is I'm going to 0 to 1, 1 minus 2x to the 1/2, and then we can do our antiderivative, dx. All right, so let's do the math. Math is, we get an x out of that. We'll add a power and then multiply by its reciprocal. So that 2 is going to be multiplied by, this would become, we add 1, we would get 3/2 multiplied by its reciprocal of 2/3 plus x to the second divided by 2. And we're going to be going from 0 to 1. All right, so there's my antiderivative. Let me do some of the math here. If I clean this up a little bit, we're just looking at x minus 4/3 x to the 3/2 plus, maybe write it as a half, x squared, something like that, from 0 to 1. Okay, let's plug in our 1, plug in our 0, and let's find the area. So we'll have pi. If we plug in 1, we'd have a 1 minus 4/3 times a 1, so just minus 4/3. That's just going to be a 1, so plus 1/2. And then when you plug in 0, all of that goes away. And so we just got to put this all together. So common denominator would be sixths. So that would be a 6 sixth minus 8 sixth minus 3 sixth. So we have a 6 minus 8 is, that's plus, not minus. 6 minus 8 is -2. -2 plus the 3 is 1. So 1/6 times pi, or pi over 6 is my volume. So a little bit tricky. Visual's huge. Trying to figure out what is this height all along the way, so then we can rotate it around and create these cylinders to create these volumes. And that is basically taking the high value minus the low value, high value minus the low value, simplify it out, and then go ahead and do your math.